guilt with my gasoline cars. Initially, I just ran gasoline, and I knew what I was putting out there in terms of hydrocarbons and oxides of sulfur and oxides of nitrogen.
Not guilty enough to do anything about it, well, but you felt guilty.
No, I did a little bit. I started going in terms of alcohol-based fuels, right? So even my minivan runs on alcohol because I wanted to be able to do something a little bit better. But I still wanted more, and this, I feel that I have the performance without the inherent guilt.
Right.
I really do.
I know this is a racing car, but it rides like a road car.
Thank you.
You can drive this all day.
Oh, thank you.
It's great.
Thank you, Jay.
So Jay Leno's garage, the car we're featuring today, well, it looks like a Porsche 935, but with a difference. This was built by Bisimoto out of Ontario, California. Our friend Bisi is an amazing engineer, builder, kind of the epitome of the American dream. Comes to this country and builds a tremendous business. He's got a huge following. He's been on this website before. You might have seen his 1,000 horsepower Honda Odyssey van. Just, you know, Civics with crazy horsepower. Well, let's bring Bisi in. Bisi, come on in, my friend.
Hello, Jay. How are you?
Good to see you again.
Always good to see you as well.
Good to see you.
Thank you.
Now, I know, like Dylan and 65, you have gone electric. Isn't that correct?
Yes,
I
have.
That's right.
It's a new frontier for me and one that's extremely exciting.
Okay, so what do we have here? We have a Porsche 935-like body.
That is correct.
Built on a purpose-built electric, or is it a gas engine frame and it's converted? What do you have here? Initially,
it started its life as a 1984 Porsche 911.
Okay.
It's like a G-body, and I found this in Palm Springs in a garage. The president of the PCA was the one who brought it to my attention, and he was destined to a life of never seeing a track or street again.
Right.
So I decided to rescue it from Palm Springs, bring it over to Bisimoto, infuse a proper Kremer 935 body on it, and electrify it to boot.
Okay. Now, is it all-wheel drive, two-wheel drive? What do we have?
In this case, Jay, it's a rear-wheel drive setup.
Okay.
And one I'm very, very proud of.
Right. Now, I would imagine the weight distribution is probably better than the car originally because you're mid-engine rather than rear engine.
That is correct. As you know, most 911s, 930s, especially those of the old school era, tend to be quite tail-heavy.
Right.
In this case, because I have batteries in the front, batteries in the rear, and the motor shifted a little bit towards the center of the vehicle, it's almost a 50-50 weight distribution.
Now, what electric motor are you using on this?
Well, it's very interesting. You know, you hear about Tesla here and there, so I took a Tesla large drive unit and modified it heavily in the normal Bisimoto fashion.
Now, how do you modify, or is it hot rodding? What is it you're doing?
I guess we could call it hot rodding, couldn't we? Because it's the new era of hot rodding, is, you know, using electrics and electronics to have a lot of fun. Now, in this case, what we did differently is, you know, if I take a step back and think about what I could do to make an EV conversion very successful, I think about performance and safety. Those are extremely important. So, taking a factory drive unit from a Tesla, we can modify it internally, modify the internals with the boards themselves, use a limited slip differential from, let's say, like Quaife, because the ones from Tesla are usually quite open and use braking systems to be able to modulate how much power goes to each wheel. But it's something that I want to keep a little analog. I want to go a little bit old school.
Gotcha.
So I employ what is known as an AEM VCU, and that's a very interesting control unit which does a great job in allowing me to keep fail-safes in place. I can have different modes of power. I have the opportunity to make sure that things are safe, even derate power if the battery temperatures get a little high or if we have a lower state of charge. It's a lot of fun, Jay, and what I created here is a beautiful 475 kilowatt setup, which for those who are not into kilowatts, is 636 horsepower.
Okay.
With a lot of torque. So, Jay, she's a lot of fun.
Now, let me ask you something. When you modify an electric motor, are you modifying the motor or just the amount of power going to it and related systems? I mean, you don't pull it out and rewind it or anything like that.
No, the wind is the same as factory, just like you would with, let's say, a standard gasoline car. And let's say you flash tune it and you get a lot more power from it. You push the envelope a little bit further, but within envelopes that are very comfortable. For example, the factory RPM limit on the motor I use is 15,000 RPMs. With the AEM VCU, I was able to push the limit to 18,200 RPMs.
Now, let me ask you about that, because obviously they've limited it to 15,000 because they think it comes apart at 18.
Not necessarily, because we push the envelope past 20 and still not have failure. But I like to be able to, as you've seen in my other cars, I like to be able to push the envelope and back off a little bit to allow for that nice safety measure, because safety is extremely important to me.
Because I know in the new, I have the Tesla Plaid. It's got the, quote, hot-rodded electric motor. It has the carbon sleeve rotor. So that apparently can rev to 22,000, which means you would probably take it to 25.
Very possible.
Okay.
That is correct. And
Okay.
the only other physical attribute that I infused into that motor assembly are the bearings themselves. So I use a bit of a ceramic matrix to allow for a lot more fluidity and for higher RPM capability without coming apart as well. But apart from that, it's been a blast. And having controllers that can allow us to modify things, even things like launch control and the duration, it's just a wonderful thing. This is like the wild west when it comes to performance for the future. And I'm happy to be at the forefront of it.
Well, that's pretty amazing.
Thank you, Jay.
Okay, and of course, there's no transmission. It's just same
No transmission. It's a direct drive. The final ratio is 9.73 to 1. We don't typically see that in petrol engines, but this allows us for a single drive. So therefore, I don't have a transmission per se. It's just like a, how should we say, an integrated motor and transaxle is what exists in this particular assembly.
Now, a Tesla probably weighs 5,200 pounds because you need 400 miles of range. Obviously, the smaller the battery, the lighter the vehicle, the faster it goes, but the less range.
That is correct.
Put it, how much percentage of Tesla battery, although they might not say that, do you have here? Is it half as much, a third, the same? You see what I'm saying?
I would say more like a third. But instead of using Tesla-based batteries, I have LG Chem cells, which gives me a total of 32 kilowatt hours. I have a 16 kilowatt battery pack in the front, another one in the rear. I use what is known as an Orion BMS to be able to monitor the battery packs, their temperatures, and their balance to make sure everything is proper. And that way, if I don't misbehave, if I drive like a human being, I can get 100...
Well, that's not going to happen.
I get about 130 miles to a complete charge. However, if I drive like a madman, I get about 100. However, there is a little bit of a blessing there. So as you can see, like a standard 935 that raced in Group 5 in the 70s and 80s, I have two apertures on the front hood. One allows for a J1772 port, the regular charging you may see at your home in the socket in the wall, or if you have 220, you can just plug that in. But because of my onboard charger, and yes, electric cars have onboard chargers, it will take me 9 hours to completely charge. However, if I look at this second opening here, this is what is known as a CHAdeMO fast charge. So that's a DC to DC. You can find that commercially anywhere here in California. Pretty much in the world, it's pretty popular, thanks to Nissan and some other manufacturers. When I plug in, 36 minutes, I can go from completely depleted to completely charged and go and have some fun.
How is the wear and tear on the battery itself and that kind of a charge? That's not a charge you would want to use on a nightly basis, correct?
Well, I could, but it could, you know, because it's now 500 volts going directly to the battery. That's a lot of current, a lot of voltage. It could reduce the life slightly.
That's what I'm saying. I mean, it's like the slower you fill an electric car, the longer the battery is going to last.
Absolutely.
Like I just leave my Teslas plugged in all the time when I'm not driving it. And my other one I drove for 7 years with maybe 5% depletion. And that seemed about the right way to go. Now, these are also water-cooled batteries,
That is correct. That's correct. You can have the opportunity to, initially when I built this car, it was like I used ambient air to cool. I used some type of convection and radiation, but now it is liquid-cooled as well.
Yeah, because you can't, unless you're 74 degrees.
Understood.
You lose it on the top end, you lose it on the bottom.
That is correct. And plus, when you're charging, especially rapid charging, it does heat up the batteries quite nicely. And you need to be able to, especially with lithium-ion batteries, you want to keep it in a certain temperature to prevent what is known as thermal runaway. You don't want that.
And what is thermal runaway?
Oh, something very bad. That's when your battery temperatures go up exponentially, resulting in a fire.
Okay, now I think that's called a fire. This is what I love, you know. This is what I love. You know, like the electric cars who catch, no fire. You got a thermal runaway.
There you go.
But, you know. So, so obviously you would catch.
Yes. So what happens, once again, with safety, because that's very important, if I see temperatures starting to increase quite a bit, the controller, the AM controller, allows me to derate or remove power or prevent much power to be demanded from the batteries to allow them to cool down. As a matter of fact, I take that a step further. Batteries, just like humans, if you demand a lot of us, it kind of wears us out a little bit, so we need time to recover. So with this, if you have any what I call pulse driving, where you're just flooring it and have a lot of fun, it would allow for an 80% power commitment for 30 seconds to allow the batteries to recover and feel better. And that does great things to prevent thermal runaway and also to enhance your battery life as well.
Now, is there any advantage in a race car to regen, or are you better off without it?
I love that. Jay, you're so knowledgeable. Yes, there is. You know, for me, range is important. I have a 2013 Viper GTS, and It was my goal to build an electric car that can get similar range to that 120 miles. If I have a lot of fun, I can do that. And I achieved that with this particular vehicle with similar power output as well. So that being said, for me to try and extend that range as much as possible, I use my braking system. So when you let off, you notice when you do drive this, Jay, you notice that when you let off the throttle, it tends to put energy back into the vehicle.
Right.
I allow for 75 kilowatts of energy to go back to help extend my battery life and keep you going for a longer range. Now, the beauty of that, once again, using electronics and safety, you can imagine if your battery is completely charged, you don't want to keep putting energy into it.
Right.
So I use, once again, the microprocessor in my controller to allow for that not to happen. So when I'm fully charged, it doesn't allow for a lot of regen back in. But as my state of charge goes down lower, more and more energy is allowed to go in the battery pack, hence more range.
Okay, now as a regen, when you're coming down from high speeds, I assume in an electric car, it needs to cool at times.
That is correct.
So regen is the same as accelerating, except it's backwards.
That is correct.
But it's still producing heat.
Yes, it is. And you still need to cool the batteries down and keep it at a certain temperature.
So you really have no way to cool.
Actually, we do. So in the very front, I have a GT3 radiator made by CSF. And that has a cooling system that not only cools down the inverter, which needs a lot of energy, which creates a lot of energy also. The inverter is what converts the DC current to AC. And the DC is what the batteries produce. AC is what my three-phase motor requires to allow for any kind of movement. So that cooling system cools down the batteries and inverters. Yeah. So it happens constantly. And I have pumps in the front and all that fun stuff. When I turn it on, you hear a nice little hum. Yeah. And that's my water pump.
And the real key in electric cars, especially something like a race car, is the wires.
Yes.
The wires. Because the wires are essentially your fuel line.
That is correct.
If you have a small fuel line, you're not going to get any power.
That is correct.
So you need a big... Are you just using big copper?
Very large 2/0 copper throughout the entire vehicle.
Right.
Orange, of course. And do you know why I have them in orange color?
No, go ahead.
Well, just in case there are any emergency services, not that I ever need them, but if we did, to show them not to cut those wires.
Right, because that could cause a thermal runaway.
Or worse.
Yeah, I got a 3rd-degree thermal runaway in my hand.
And what's interesting is, guess how much voltage I'm running on this?
Okay, I would... 478 volts.
Wow, you're close. 403.
Oh, okay.
Yeah, 403, you're there. And you know, with that, you can imagine it won't be fun if you get electrocuted with 400 volts. That won't be fun at all.
I was always told, like a lot of cars now have 48 volts.
Understood.
And because 48 volts is the amount of voltage the human body can take without going into shock or dying. Some people could take more, but the average person touching anything more than 48 volts, you're going to probably go down. So that's why a lot of cars now, they have two batteries.
Makes sense.
But no more than 48 volts.
Yeah, understood. Okay. But think about what we're doing nowadays with 400 volts. Porsche factory, 800 volts.
Right.
I hear that Lucid is playing around with 1,200 volts. And very soon, people are now delving into 1,600 volt systems.
Wow.
And what happens there, we have more efficient opportunities for motors. You have better efficiency. I'm at 90%, but that can go up even better if you have higher voltages. And you have the opportunity, as your state of charge goes lower, you can still have energy. Because that's the one Achilles heel that I've seen with performance EVs.
Yeah.
When the state of charge goes down, so does the performance potential.
Right.
Think of it as a gasoline car going up in elevation.
Right.
That's very similar to what we see with a lower state of charge. But with higher voltages, it's not as much as a problem.
Okay, so I mean, the thicker the wire, it's almost limitless the amount of power you can put into an electric motor if you just had thicker and thicker wire.
That is correct. Just think of it as energy flowing very nicely.
Yeah.
You don't want any resistance. Resistance creates heat and lack of energy.
Right, right. Okay. All right, very good. Now, take us around. Well, how do we take this red deck
Very
off?
simple. You know, just to pay homage to the original 935s, there's a little push release there. So you just push that in and pull out.
Okay.
And we have another one in the bottom, right here.
Where's the other one?
Right here in the bottom on the side. So you can see it sticking out right there.
Oh, right here.
Yep.
Okay.
That's it. Okay. And I'll just need a little help to just lift the back up.
Oh, I see. Here we
back
go.
a little bit. And we are off.
Okay.
And that's it. All right. So, Jay, you see this? I did this just for you so you can see all the internals. So, what I
not
have
as
here,
sexy as the flat six.
It's not, but quite useful. You know, I've seen a lot of conversions that you may see, you know, on YouTube or some other people have done. Some of my peer engineers put together these conversions. And they seem to be very convoluted.
Yeah.
Meaning you have all these switches you have to hit. As an engineer, I appreciate that, but to be able to hit a switch for a negative contactor and positive contactor and pre-charge contact, that's a lot. So I use an old drag race setup, like an old PDM from Race Pack, to control all electronics. So what we have here is my onboard charger.
Right.
Yes, that charger we see on the wall at home is actually a safety device. This is actually the charger itself that takes AC and converts it DC to the battery.
Now you have that in here because this is a race car.
Actually,
I mean, because it's a street car. Would you use that in the race car?
I would.
Oh yeah, because you use, okay.
By the way, every EV has an onboard charger.
Yeah, yeah.
Because all the wall does is send in AC, and then you need the AC to be converted to DC to charge the batteries. And then you see the thick wires you're talking about, nice and orange? Yeah, you don't want to cut into those. I have a main cutoff switch right here.
Right.
I have a pre-charge contactor. I have very large fuses just in case, God forbid, something happens. I have a negative contactor, positive contactors. So this is a DC to DC converter. As I mentioned to you, my system operates at 400 volts. What that does is it takes down 400 to 12 or 13.5 volts for all my accessories like the horn, the lights, etc. And
so you have like a Vanna unit to bring it down to 12 volts?
That's what this does. So this right here with the fan, that's what allows for that. So what happens is when I turn the key on, and this car is so easy to drive. Even my grandmother could drive it, Jay.
Right.
You just turn the key on and everything comes on. The smart wire PDM does everything. Turns on the negative contactor. When it makes sure that all batteries are safe, it turns on one battery pack. If both battery packs are within 3 volts of each other, it handshakes and allows for the other battery pack to come on, and the car is alive.
Let me ask you a question about, a couple of times friends call me, oh, my car won't start. And I go to the house, and you open the hood.
Yes.
And there's a big glob of green stuff. It looks like a beehive on the battery.
Yes.
You chip that off. Do you get that with electric cars?
You can.
Or is there so much voltage that it literally just flies?
Oh, no, you can. So to prevent that kind of condensation, I do have some, that's why it's a little shiny. I have a paste that I use around all my
But occasionally, if you're ever to do maintenance on an electric car, you just want to make sure all your connectors are...
you want to bring it to me and I'll handle that.
Okay.
You won't do that yourself. And this is what is known as the Orion BMS, the battery management system. And you see all those wires going there.
Right.
There are 96 cells in the back, 96 cells in the front. The master BMS and the satellite monitors and communicates via CAN, the controller area network setup. So 2 wires communicate and make sure that everything is fine. Well, all the driver has to do is just enjoy the car.
Right.
While we do all the hard work and all the design as well.
Yeah, no, that's great.
Thank you.
That's great. And you could convert this back to a 911.
If you notice, there's no cutting whatsoever.
I was going to say, I'm looking at it saying, I don't see any cuts or anything. So you
Absolutely.
Could put,
When a client comes by and brings his 911, 930, 912, whatever the case may be, this is a 100% reversible process.
Yeah, and the cool thing is, everything is below the axle. Most... guys put a big V8 in here, and then you've got all this valve train up there. You got that gyroscopic stuff going on. So this is all down low. So
gives a nice center of gravity.
Yeah. You're not going to flip it. Yeah.
And underneath here, of course, the battery packs are right underneath there as well. And it's very nice. As you mentioned earlier, it's more like a mid-engine setup. See how
well, it is a mid-engine. I mean, anytime you're in front of the rear axle,
absolutely,
it's mid-engine rear. Like the SLR is mid-engine front because it's all the way front. So, well, very cool. All right, let's put this back on.
Sounds good.
Well, let's take it for a drive.
Sounds good.
Gotta climb over this roll cage. Oh, that's not bad. I can't wait to hear the roar. Oh, that's right. Yeah. So I guess that's not going to happen.
The whir.
Can't wait to hear the whir of that engine.
So indicators work, everything works.
Good.
I even have daytime running lights, just like newer cars are.
Right.
I try to combine as much.
Yeah, she pulls nicely.
Thank you. I try to combine as much new and old tech as possible. Or better yet, I like to put in as much new technology and still remain true to the old Group 5 heritage.
It's funny, you can't sell something before it's time.
That's true.
Like the Chrysler Imperial used to be a very imposing looking car. Then in 1934 they come out with a thing called the Airflow, which is very streamlined, and it looked like you know, the Santa Fe Express, one of those Art Deco trains.
Right.
And people just, because it didn't have that imposing grille, it didn't look like an impressive car.
Understood.
You know, but it was better in every way. Couldn't give them away. They finally had to go back to a traditional radiator.
That is so interesting.
I mean, the thing that makes this appealing to people, it looks like a Porsche 935. Oh, but it has the advantages of all the electric, the torque, and the power.
Absolutely.
If it looked like a Silver Bullet or some generic,
people wouldn't even.
What is that thing?
Yeah, exactly.
Yeah.
Oh, it's beautiful. It looks inside. It looks like an old Porsche. Smells like an old Porsche. Right. But performance, it's way nicer. I like that torque.
Oh, I love the torque. And there's no torque steer. It just pulls nicely.
Thank you.
Tell me about those wheels. Really unusual looking.
Yeah, Bricks and Forge, there's this company, you know, young guys, and they really love old school racing and so on and so forth. And we want to combine the elements of the old Group 5 racing, being the turbofans that help with cooling brakes and so on and so forth, but also giving nods to Formula E. So you see the little vents around it, that's like a Formula E influence.
Right.
And then the turbofan itself is a, you know, actual turbofan that you can use to cool the brakes and all that fun stuff.
Now, I imagine with regen, do you need to cool the brakes as much?
No, you don't. As a matter of fact, one great thing about electric cars with regen is you rarely go through brakes because most of the braking is done by feeding energy back into the battery pack. So your brakes pads last way longer than a standard gasoline vehicle.
But there is no regen on the brakes. The regen is on the deceleration.
And there's a little bit of brake regen as well. It adds as well. So for the first 20% of braking, regen kicks in, and if that doesn't stop you enough, everything else is visible. So I have micro switches on the brakes as well to help.
Oh, so there's So lifting my foot off the throttle provides certain amount of regen.
And then tipping into the brakes.
And then touching the brake gives me more regen. Oh, I thought it was one or the other. I thought you were two completely different. Well, that's it.
And what's even better is when you let off the throttle to regen for safety, the brake lights actuate.
Right.
To allow that. Something that OEMs do, but I do the same in my conversions.
I remember back in the 80s, I had one on my motorcycle, my CBX. The guy had a deceleration light.
Oh.
So if you're going fast, you get off the throttle really quickly. Bright, and it got duller depending on how.
Interesting.
So, yeah, but it, you know, they tried it on taxis and it prevented accidents because it was really in your face, and then if you touch the brakes lightly, just the regular brake light.
Interesting. You know. In my case, when you decel and the brake lights come on, there's a little eco light that comes on a dash, on the AM dash, and shows eco. You know, like a little economy here and there, but it shows that to also remind me, or the driver, that the brake lights are functioning properly. And I have everything from battery temps there, to power percentage, to dark position percentage, to voltage.
Right.
Yeah, all the fun stuff. And state of charge. So we can know how much batteries we have left.
And it's completely manual steering.
Completely manual. Just
no
like
assistant, no electric assistant.
But it's not so bad, is it?
No, it's fine.
And the Momo steering wheel has that's a flat steering wheel from Momo. Kind of invokes the racing from 1960s.
Right.
And that's what I have on that to give you that nice, once again, old school feel. I don't want to take away too much from the heritage.
Right.
I kind of wanted a little bit of the old and the new. I love that. I just love that meld, Jay.
Oh, yeah.
I mean, even my dash has, even my from the horn button, I even had a little houndstooth.
Oh, yeah.
And the livery, once again, the livery is a nod to a Japanese team that raced 935s in the 70s and 80s, known as Team Gozi. Yeah. And then Andy Blackmore, who's an accomplished designer, he did a livery as well, kind of combined my Bisimoto dark gray metallic look with that nice hot pink fluorescent to it. And this chap is very talented. He's designed liveries for F1, he's designed liveries for video games, and he was kind enough to lend his expertise and genius to this particular project.
And you build cars for people all over the world.
All over the world.
Last time I spoke to you, you had a guy in Finland.
That is correct. He had slant nose that he sent to us.
Oh, okay.
And I have another 935 that was sent to me by a good friend of me from the UK.
That's interesting. So you just send your car literally halfway around the world to a guy you never met, and a check.
Yes.
So you sent your car and a check.
That is correct. Our reputation precedes us, and
Yeah, no, well, it
it's a good
does.
place
You
to
have a
be.
great reputation.
And the thing, Jay, I came to this country with 2 suitcases.
I know. Well, that's what I like. I love the American dream, because what happens? You come to America, and you work hard.
Yes.
And then you eat hamburgers and pizza and French fries, and you listen to music.
Yes.
And then your kid becomes really lazy. I remember, I used to do this thing called jaywalking, where we'd knock on the door, we'd ask people questions.
Right.
I remember we went to one house. The grandfather came to the door, spoke no English, just Spanish. He said, "Let me get my son." The son came to the door, spoke Spanish to English.
Right.
And then I met his son, who had a T-shirt with an obscenity on it, and he was playing some video game and couldn't have been bothered. And you just watch it. Whatever. America it makes you an American. That's why we need more immigrants all the time.
I agree.
Because it's a resurgence of energy.
Yes, sir. Yes, sir. But the thing about the United States offers so much opportunity. I've had the best education in this country. And above and beyond that, my father, I remember when leaving, gave me a bit of advice. He said, "Bisi, America, that's the place to be the best you could be, and the worst that you can be."
Right, exactly.
So if you want to be completely useless, there's everything here. But if you want to be the best in any facet of your life, America is a place to do it.
Yeah, no,
And he's
that's
right.
great. I love that sort of American dream.
Yes, sir.
Is your dad still with us?
Yes.
Oh, so he gets a chance to see you.
Oh, he visits. He's so proud.
Yeah.
He's so proud.
Yeah, that's wonderful.
I come from a family of scientists. My dad is a geologist. My mom's a biochemist.
Right.
A brilliant biochemist. And my family, my siblings are all scientists as well. So, it's just I'm the firstborn, so I kind of had to lead the charge.
Right.
You like that? Lead the charge?
Lead the charge. I see. Yes, very good. That's shocking.
It is shocking. It's electrifying.
Yes.
Oh, man. That's another thing I love about electric vehicles. I'm an enthusiast first before an engineer. I just love the fact that there's no lag. It just
There's
feels
no lag.
so good.
And I'm past the point now where the gas price doesn't matter. $2, $2.60,
Right.
$2.50, no problem. I'm seeing $8, $9. Now I go,
It's crazy.
no, I'm going to take something else. I'll take the Tesla, which is
Understood.
faster,
Of course.
and cheaper.
If we had a conversation about electric cars 5 years ago, you couldn't pay me to do anything with it. But it's just, I was a diehard petrol head, diehard.
Oh, yeah.
But now, after building my own and seeing the experience, and you see it's not completely quiet. There's a nice supercharger like whine in the back. It's different, but not bad. Just different. And I love it.
Well, when I meet people that say, I don't like electric cars, what do you want to win the race or not?
Exactly.
What do you want to do?
Very
Okay.
true. Very true.
Now, what steering box is this?
It's a factory 930.
Oh, it is.
Just
Okay.
like factory.
So
It's
it
just-
did not have any assist of any
They didn't
kind.
have any system. As you remember, this chassis was originally a 1984 chassis.
Right.
So it has everything like you had seen a 1984, 911, 930. With exception of only 2 pedals opposed to 3.
You would like my own magnetic,
Ah,
because that's a gas engine
okay.
which drives an enormous electromatic transmission,
Interesting.
because batteries were not very good
Right.
in the day. It's an electric car that's powered by an internal combustion engine.
Interesting.
And it's 1960. Yeah.
No way.
Yeah.
That's
and
amazing.
it has regen and everything in it.
Oh, that's fantastic. I love technology.
In fact, the Enst electric transmission was developed in 1897.
Really?
Yeah.
So I gather electric vehicles were pretty much, right there at the beginning.
Oh,
And then somehow-
they predated gas cars.
Yeah, then somehow gas cars took over.
Well, you have to think of it like Beta and VHS back in the 70s and 80s. Beta was actually superior technology, but VHS, I guess, was cheaper to manufacture.
Understood.
So they flooded the market.
Of
So
course.
it became the standard. What are you going to do? Everything was VHS.
So petrol cars, or better yet, gasoline cars have had a 100-year start in advanced technology over electric vehicles.
Well, the first land speed record was electric.
Wow.
In fact, I have a battery at the garage that was made by Thomas Edison.
Okay, very nice.
It was an experimental battery. Edison wrote a letter to Henry Ford saying, I have something that will replace the Model 5. It's a battery that will make the electric car viable.
Wow.
But it never did.
Oh my goodness.
A lot of people know Henry Ford used to work for Thomas Edison.
I didn't even know that.
Yeah.
I look forward to battery technology improving as time progresses, and hence, all of my builds can keep the motors in the same spot,
Yeah.
but the batteries can easily be modular and upgraded as technology improves.
Oh, yeah. In fact, I would say battery technology has come further in the last 20 years than it did in the previous 80.
I agree.
Although my 1909 Baker gets 80 miles on a charge.
That's not bad.
No, that's very good.
That's amazing.
Well, you're only going 22 miles an hour.
Understood.
But don't forget, all the roads were cobblestone.
Understood.
Thomas Edison came out with an alkaline battery. I have one of the few he invented. And the idea was you would fill it with alkaline, charge it until the alkaline, quote, wore out,
Right.
as liquids do sometimes. And you could use it over and over again. But it never quite had the potential that he envisioned.
Understood.
And it's powerful, but not brutal.
Yes.
You know, it's so linear.
It invokes a good confidence as well doing that, and you know what to expect. Plus, she only weighs 2681.
I like the fact that the engine does double duty, both braking and powering.
And if you need a lot more than the regen system allows, there's very nice stop-tech brakes all around to help you mechanically as well.
Now, if somebody brought like a 911 to you and wanted to convert it, what would the conversion run? Can you say?
Yes, depending on the options, could be anywhere from $80,000 to $90,000 depending on options.
80 to 90,000.
This cost me a little bit over $240,000 to build.
240? Yeah. Now you have a lot of manufacturers like Ford. They're making a crate electric motor.
I saw that.
Which is $4,000.
Yes.
Which is what, about a third the price of, you know, a crate internal combustion engine.
That is correct. But on the same token, I still yearn for that extra power, more than, 200 or 300 horsepower,
Right.
So as a performance enthusiast first, having, 6, 7, 800, 900 horsepower EVs, that's like a blessing for me. It's something I look forward to. And when you have places like Pikes Peak, where there's elevation, the electric motor could care less.
Right.
So it doesn't matter where you are.
I believe the Lightning motorcycle set the Pikes Peak record.
Yes. And VW's done quite a bit as well with their ID racer. And nowadays in California, the United States period, where emissions tends to be a challenge, the fact that I have a vehicle that looks like this and is a zero emission vehicle is 50 state legal.
Yeah, that's great. Yeah, you don't have any problem. And you can convert back. Porsches are expensive, but they're not rare.
That's correct.
There's thousands of crappy, beat-up Porsches with blown engines around. Not a lot, but enough that you could do a conversion without the Porsche Club of America showing up at your door all upset. You know what I mean?
Very true. And if you have the itch to go back to gasoline, you can easily convert it back without qualm.
It's funny, it's all what you're used to. I mean, just as today Model Ts are not worth any more now than they were 25 or 30 years ago, because people have no relation to them. They don't understand them anymore. And kids born today, really don't have any need for an internal combustion engine. It doesn't, by the time they're adults, it will not do anything better.
Understood.
It won't have the range. It won't have the shifting of weight as you use the liquid. You're not dropping 180 pounds all of a sudden.
Understood. I have a weird inkling, Jay, that years from now, people look at us like, you actually used to dig something out of the ground, refine it, and put in a car for transportation.
Yeah.
We may get there.
Yeah. Well, let me ask you this question. How much does battery energy weigh? If I take a lithium-ion battery that's fully charged and I weigh it, then I put it in the car and exhaust it to zero, does it weigh less?
It does. In grams, it does.
It does?
Yes, I've seen studies where they actually weighed a fully charged battery pack. Bear in mind, it was over 100 kilowatt hours.
Right.
But there was a weight differential between the two.
And what was the weight differential?
It was in grams. It was a few grams.
Just a few grams.
A few grams.
But I think, I can't remember the name of the English scientist who weighed smoke. Because he put a cigarette on, he'd smoke it, and then and the smoke weighed different.
Interesting.
Yeah.
Interesting.
But that's kind of, what does energy itself weigh?
There is a weight to it. There is. But I look forward to the advent and propagation or improvement in, let's say, because I'm hearing a lot about supercapacitors nowadays and other battery cells that have more density, more energy density, and less weight, have less weight.
Yeah.
I mean, when that comes to the market, I mean, that's it. I mean, imagine having a vehicle that weighs less than this, but can get 700 miles to a full charge. And they can accept charge even faster, where you can charge up a 700-mile pack in 15 minutes or 12 minutes or 8 minutes.
Oh yeah, I guarantee a kid born today, by the time he or she is 21, and your car's weighed how much?
Exactly.
It's like you're a dinosaur.
So what do you think so far?
Oh, I think it's fabulous.
Nice, thank you.
It's very impressive.
Thank you. And everything works, horn works, indicators work. I have daytime running lights in the front.
Right.
There's a company in LA known as 911 and 911 Designs, and they have this Raven 9 headlights that they tend to retrofit better optics in older classic Porsches. I was able to use their services to be able to create this for the 935. And yeah, once again, taking all that's good from the future and combining it with all the things we loved from the past. And this is the result. But I feel my next one, I'm going to put in some more creature comforts, like AC and power steering. And I do have a Bluetooth radio in here, which is invisible because I like the minimalist look. But make it a little bit more comfortable. When I'm done with that, I'll bring it by and have you take a look.
I'd love to see that.
Sounds good.
I have to admit, I always am enamored of dashboards with all kinds of information. Differential temperature, just all the different, I just like having that information.
Sounds good.
At my fingertips.
Understood. And what I have is an AEM dash there, which is a CD5, and that gives you quite a bit of information. You can scroll through different screens. But I also wanted to make it look as user-friendly as possible, where you really have to take your eyes from the road. You can just glance down and keep going.
You watch people start stealing electric vehicles to get the copper wire.
You know what? Oh, don't put it out there, Jay.
Yeah, I know.
I know. It's gonna happen. And even batteries now, how expensive lithium-ion batteries are. That is one of the most expensive components in a conversion like this, are the batteries.
Yeah. What do you think the hybrid battery for the McLaren F1 is? I mean the McLaren P1.
I couldn't imagine.
How much do you think the battery is?
I couldn't imagine. 70 grand?
180.
Oh my goodness.
Yeah.
Wow.
Yeah.
Wow. That's a pretty penny.
But when you figure the average fill-up these days is going to be $100
easily.
But it's quite relaxing to drive. And there's no engine, there's no heat soak.
Understood.
You know? And what did you call a fire? A thermal, what was it?
Thermal runaway.
Thermal runaway. That's my favorite thing.
Thank you, Jay.
Thermal runaway.
But it's not a good thing to happen.
No.
And that's one of the challenges with lithium-ion batteries.
But I don't know. I notice, like, whenever there's a Tesla fire, and there's millions and millions, tens of millions probably of Teslas out there now.
Understood.
They still don't seem as prevalent as a gasoline fire.
Understood.
And there seems to be way more gasoline fires.
Understood.
But to the general public, when those headlines start,
of course.
Oh no, God, those things.
Exactly. And because they're newer and it's more sensational to talk about those things. But you're right. I mean, the way some people even attack electric vehicles, it kind of gets to me sometimes. Especially the fact that I converted a Porsche or a 935-ish looking Porsche as well. But if you really think about it, if I want to be mean, I can say, well, on a petrol car, on a gasoline car, you're sitting on a liquid flammable bomb.
That's right.
You're sitting on a tank of flammable fluid.
And the nice thing is, with an electric car, if you sense there's a fire, you can stop it at any time by pulling that main.
That's correct.
That main. Most people don't know where it is.
Understood. That's correct.
Now you've cut the electricity. Yep. It's over. Fire stops.
But to be honest with you, I do carry a little extinguishing stick behind me. There's a company called Element, and they make extinguishers that also extinguish electrical fires. So just in case, I have this stick, I click it, and well, from afar, from a distance, I'll do that. But safety first, no matter what. Gasoline or electric, safety first.
I know this is a racing car, but it rides like a road car.
Thank you.
You can drive this all day.
Oh, I thank you.
It's great.
Thank you, Jay.
How much does air conditioning pull from something like this?
Oh, it can be quite. It depends. There are electric. Mercedes-Benz, Hyundai, Tesla. They make pretty efficient electric compressors.
Right.
But but it can. It can decrease. For example, my 100-mile range, it can take off at least 20.
Oh, right. Yeah.
It can.
Well, I remember the old days, like I've got a Chrysler Imperial. It's got dual air conditioning.
Oh, wow.
And you go along, you turn it both on, and you just feel it slow. Now you got to give it more gas.
Just make up for it.
Yeah, get those compressors going.
You know what's interesting? Modern engine control units do that automatically. Whenever there's a demand, it raises the idle or raises the requirements to allow to compensate for it. And you still use more fuel. A lot of people don't think about that, but energy is not free. Whether you're using a heating system or cooling system, it does take energy.
Well, that's why most electric vehicles, they cool the seat.
Yes.
Or they heat the seat because they're not having to heat or cool the entire cabin.
Understood.
Yeah. No, but this drives and handles wonderful.
Thank you, Jay. I appreciate the kind words.
And with electric motors, when you get them, I imagine you usually get them from Teslas that have been in auto accidents.
A little bit both. You know, I've been kind enough to have some relationships with some engineers.
Well, what I'm saying is, it's not like buying a second-hand internal combustion engine where it has so many miles it's worn out from friction, you know?
Electric motors, the beauty is that they have much fewer moving parts as well.
Yeah.
And very little maintenance.
Yeah.
So, you know, one of the things I have my eyes on, sets on it, like maybe, you know the old school Rolls Royces, like the Silver Spurs?
Right.
Beautiful cars, very luxurious, but not the best in terms of reliability.
Right.
Imagine having an electric one.
Well, that's what I mean. I would have thought Rolls-Royce would have been one of the first with electric.
I agree.
Because the whole thing is quiet and silence and all that type of thing, you know. But yeah, you'll see. Actually, I drove 15 years ago an electric Rolls.
Oh my goodness, how was that experience?
It was interesting. It didn't have a huge amount of range.
Okay.
But it conveyed what a Rolls Royce is supposed to be.
Good.
Silently, you know, you only hear the clock ticking and all that.
So Jay, what if I built one of those? Would you be able to give me some feedback on it?
Sure, that'd be fun.
Sounds good. Consider it done.
And it is funny to watch the thing change, because even guys I know that are internal combustion enthusiasts understand pollution. And in the old days, it was like, who cares? I just got that Hemi. I don't care how much smoke I blow, you know. And those days seem to be people feel a more sense of responsibility about the hobby, you know. So the fact that if you can get twice the power at half the cost, even less than half the cost, really, why not?
Jay, I've always had that guilt with my gasoline cars. Initially, I just running gasoline, and I knew what I was putting out there in terms of hydrocarbons and oxides of sulfur and oxides of nitrogen.
Not guilty enough to do anything about it, but you felt guilty.
No, I did a little bit. I started going in terms of alcohol-based fuels, right?
Yeah.
So even my minivan runs on alcohol because I wanted to be able to do something a little bit better. But I still wanted more, and this, I feel that I have the performance without the inherent guilt.
Right.
I really do.
Yeah, no, it's great. Well, Bisi, I'm very proud of your accomplishments.
Thank you, sir.
I love people that come to America and contribute something and make a great product like this. You know, it's really terrific. So you're a terrific engineer, a great guy, and a good builder. Thank you, my friend.
Thank you, Jason.
We'll see you again with the next project.
Sounds good. The best is yet to come.
Yeah. I want to see. Bring that Rolls by.
I will.
Did you just get that idea right now?
I sure did.
Yeah.
So give me a few months, I'll have it to you. Jay, I am very fortunate to be in this country and be in this era where I got to touch different types of means of propulsion.
Yeah, and your kids will go, you know, my dad worked with carburetors. How old is he? Oh, this thing is great.
Mm-hmm.